All right, guys, today we're getting a lot of new definitions, a lot of new words that you may not be familiar with, but the math behind it, a lot of this is stuff that you've already seen. We're just adding a few new terms, a few new words to go with it. So what we're talking about is monomials. And a monomial is, really the simplest version of it is a monomial is a term that you've seen in the past. It's a number, a variable, or a product of a number and variables with exponents. So for example, 18 is a monomial because it's a number. Z is a monomial, it's just a variable. Negative 4x squared is a monomial because you're multiplying two of those together. 2.5xy cubed is a monomial. Even though there's two variables, they're being multiplied, so that's still called a monomial. And a over 3, again, is a monomial, okay? Now you can combine all of these together to form what we call a polynomial. And a polynomial is just a group of monomials being combined together, all right? So the degree of, and the way that we write those out kind of depends on the degree of each of these individual terms. And it sounds complicated, but at the end of the day, it really kind of gets simple. So 18, if it's a number all by itself, we call that a constant. And it has a degree of 0 because there are no exponents. The way that we find the degree of a term, of a monomial, is by adding up the exponents. And 18 doesn't have any exponents on its variables because there are no variables. Z is a variable, and even though you don't see it, there's a 1 right here. So Z has a degree of 1 because of that exponent right there. This term, negative 4x squared, negative 4, we don't count. There's no exponent associated with it. And x squared has a power 2. So that would have 2 degrees. 2.5xy cubed can be a little bit confusing because nothing's with the 2.5. The x actually has a 1 right here, and the y has 3. So 1 and 3, when you combine those together, it has a degree of 4, and a to the first power has a degree 1. Okay? So these degrees down below, 8xy, again, there's a 1 and a 1, so that has 2 degrees. 27y to the 4th z to the 1, that has a degree of 5. 11, no variables, so no degrees. That has a degree of 0. That, again, is what we call a constant. All right. So you can add monomials together. And we call this a polynomial, again, but we can add the different parts of it by adding like terms. And this is nothing new for you other than the terms get a little bit uglier. Last year, you did stuff like this all the time. In fact, some of you in 7th grade, I worked with you to learn how to do some of these things. The difference is instead of 8w squared x plus w squared x, you had something like 8a plus a, and you can easily tell me that that's 9 a's. 8 of them plus 1 more, that's 9 a's. In this case, I've got 8 w squared x's, and then I have 1 more w squared x. So when I combine those together, I have 9 w squared x's. Okay, 5 bc4s, bc to the 4th power, minus 13 bc to the 4th power. That's just that's just 5 minus 13, which is negative 8 bc to the 4th power. Since these variables are the same, I can add and subtract them with each other. Now, the way that we write polynomials is we write them in order based on their degree. We want to write the biggest number first and reduce that down to the smallest number. So if you look up here, the x to the 4th comes first because it has 4 degrees. The 5x squared has 2 degrees, so it comes second, and then the x, and then the constant. Okay, so constants are always going to be last. That's one easy way to remember those. And then the rest of them just go in order based on how big their exponents are. Okay, so let's give you an example that one that's mixed up a little bit. So if I had something like -3x to the 5th plus 2x squared minus 4x cubed plus 7. Now I want to put this in order from the biggest exponents to the smallest. Well, here's my biggest right here, -3x to the 5th. It doesn't matter that this is a -3. What matters is my exponent. And then the next biggest one is this one right here, -4x cubed. Be really careful to take that negative. And then the plus 2x squared. And then my plus 7 goes at the end. Okay, so that's called standard form. You write them in order. And we give different names to these. I'm not going to worry too much about this chart. You can pause the video and kind of look it over. But we give everything two names. The polynomial, we give it a name based on its degrees. If there's no degrees, we call that a constant. We already talked about that. If there's 1 degree, so if there's just an x to 1 power, we call that linear. And this is kind of what you did in 9th grade. You worked with this stuff. Quadratics have the highest power is the power of 2. And we call that a quadratic. And that's going to be our bread and butter this year. That's going to be what we spend the majority of our time studying is quadratics like this one. And they go on. If it has x to the 3rd, we call it cubic. If there's a 4th power, we call it a 4th degree. Now, the number of terms gives it another name, and that's monomial, is because this one only has 1 term. It just has a 6. A binomial, remember bi means 2. So this term right here has a 5x and a 9. So it's called a binomial because there's 2 of them. This quadratic has 1, 2, 3. So we call that a trinomial. And again, this is kind of what we're going to focus on a lot this year. And it goes on from there. All right. So let's move on. Enough time with definitions and new words. Let's do some math. So first thing it wants us to do is to write these polynomials in standard form, then name it based on the degree and terms. So I need to write these in order. And when I look at this one, I've got a squared and a squared. So I better combine those together first. So 6 minus 13, that's -7x squared. And then I have a minus 4x and then a plus 4 that's going to come next. Okay, so that is standard form. It's in order. And my biggest degree is a 2, so we call that a quadratic. And there's 1, 2, 3 terms, so we call that a trinomial. All right, similarly, down here, 2x minus 3 plus 8x squared. Nothing can combine together, but I want this 8x squared to go first. And then I want the 2x, so plus 2x. And then I need the minus 3 to come very last. Don't forget to take whatever's in front of the term. You got to take the sign with it. Now there's a power of 2. So this is a quadratic. And again, there's 1, 2, 3 terms. So we call that a trinomial. Okay, more math. You can add polynomials by adding like terms. So I can take, here's one polynomial. Here's another polynomial. I can add them together. I just have to be careful that I only add like terms together. So when I look at this, I've got 5x squared plus 3. These parentheses don't make a huge difference because in between them is a plus sign. So I don't need to worry about the parentheses too much. I can just say plus 15x squared and then plus 2. So I just rewrote it, and now I'm going to put my like terms together. I've got x squareds. I've got 5 of them right here and 15 of them right here. So when I add those, that becomes 20x squared. And then I have a 3 and a 2. So plus 3 plus 2 becomes plus 5. That's my constant. So that would be my simplified version. Okay. Now this one, we've got to be a little bit more careful of because of that negative in between the parentheses. It doesn't affect the first part. This is still -6w to the 4th plus w squared, but I'm minusing this entire parenthesis. And if you remember from 7th and 8th and 9th grade, you remember that you've got to distribute that negative to everything on the inside. So what that means is when I distribute a negative to a negative, that becomes a positive 2w cubed. A negative to a positive becomes a negative 4w squared. And a negative to a negative becomes a plus w. So now I just look for my common terms, my like terms. W to the 4th is the biggest, and it's the only one. So we're going to put that first. There's a 2w to the 3rd power, and there's only one of those, so I can go ahead and put that next. And then I have a w squared and a negative 4w squared. So this is like 1w squared, and I'm minusing 4 more w squared. So 1 minus 4, that's negative 3w squared. And I'm left with a w at the end and no constant. There's no 2, 4, 6, 0, 8. Well, I guess there technically is a 0. But there's no constant to go at the end. So this would be my simplified version. That's my final answer. Okay, multiplying monomials and trinomials. Again, something you've done before, and I know this. Maybe you haven't multiplied it with a trinomial, but I know that you have multiplied them by binomials because there's a good number of you that I taught you how to do that in 7th grade. So let's take this and we're going to turn it into a binomial. So if I had 5 on the outside, and if I had 3x plus 2 on the inside, I think most of you fairly quickly can tell me to take the 5 and to distribute it to everything on the inside. So 5 times 3x is 15x. 5 times 2 is a plus 10. So that's how I would distribute the 5. And then you also learned, well, what if it's not just a 5? What if it's a negative 2x on the outside? And then let's put 3x plus 2 on the inside. This is the term in front, and I'm going to distribute that to everything on the inside. So negative 2x times 3x is negative 6x squared. And negative 2x multiplied by 2 is actually, that's a negative times a positive. So that's a negative. 2 times 2 is 4x. So that would be my answer there. Now, the only difference this year is instead of just binomials, we have 3 things on the inside. So I'm going to take this 5n and I'm going to multiply it by everything on the inside. All 3 of those, not just 2. So 5n multiplied by 3n cubed. The 5 times 3 is 15. The n times n cubed is n to the 4th. That was less than 1 right there. Now 5n times negative n squared. 5 times negative 1 is just negative 5. N multiplied by n squared, that's 3n, so that's n to the 3rd power. And then 5n multiplied by a positive 8. 5 times 8 is 40, so plus 40. N times nothing else is just n. So that would be my final answer. Okay, so let's try it again. I'm multiplying negative 8y cubed. I'm distributing that to everything on the inside. So negative 8y cubed times 7y squared. So negative 8 times 7, that's what? Negative 56. And y cubed times the y squared is 5y's. That's y to the 5th. Now negative 8y cubed multiplied by negative 4y. Got to be careful. Negative 8 times negative 4, that's positive 32. And y cubed times y is y to the 4th power. And negative 8y cubed times negative 1 becomes positive 8y cubed. And those are already in order. So that's it. I'm done. That's standard form. Okay. So going forward, distributing shouldn't be too tough. You've done it before. In fact, I would guess that you've probably done it with trinomials here and there. So it's nothing new as far as the big concept. It's just applying it to a little bit longer math problem. Now, this is the fun one. What if we need to go backwards? And I don't say what if we need to, because this year you're going to have to go backwards a lot. So this is a big concept that we need to get good at. And that's why we're starting it so early in the year. What if I have this polynomial right here? I have 3x to the fourth minus 9x squared minus 12x. Sometimes we want to do math with that problem that involves making it as reducing it as much as we can, or in other words, factoring it. You'll see why here in a couple of weeks, why that's important. But we really need to figure out how to factor things, or in other words, we're going to do distribution right here, but we're going to go backwards. We're going to start with this part, and we're going to work backwards and end up with the longer problem, which sometimes, well, we just got done making it shorter. Now, why are we going to go backwards and make it longer? Because it's going to make some math problems a lot easier to be able to do it that way. So you need to know how to do both. So what I need to do is the first thing I look at is the numbers in front of everything. I've got a 3, a -9, and a -12. And what I'm looking for is the greatest common factor, or the biggest number that multiplies to 3, -9, and -12. And that biggest number is a 3. Because 3 goes into 3, 3 goes into 9, 3 goes into 12. But I also have to look at my x to the fourth, x squared, and my x. And what I'm looking for is the largest number of x's that I can take out of all of these, which sounds backwards because what I'm actually looking for is the smallest number of x's, because I need to pull it out. So x to the fourth, this one has 4, this one has 2, this one only has 1. So I'm only able to pull out 1, because if I try to pull out 2, I could take 2 x's from here and 2 x's from here, but this one only has 1 x, so I can't take out 2 x's. So what I'm wanting to do, this is my greatest common factor, and I want to pull 3x out of all 3 of these terms. I want to divide out 3x. And so what's going to happen is I'm going to end up with 3x in front of a set of parentheses. And the first thing I need to pull it out of is 3x to the fourth. So when I pull 3 out of 3, I'm left with 1. When I pull x out of x to the fourth, I'm left with x to the third. I'm dividing out one of those x's. Now let's look at the -9x squared. My negative is going to stay. When I divide a 3 out of 9, I'm left with a 3. And when I take x squared and I divide out an x, when I do x squared divided by x, I'm left over with just x. And this one, -12x, I leave the negative. 12 divided by 3 is 4. X divided by x is 1. That goes away. So I actually don't even have to put anything after that 4. So my answer when I'm factoring this is 3x multiplied by x cubed, because I don't need to put a 1 right there, minus 3x minus 4. Okay, let's try one more. What's the factored form of 9x to the sixth plus 15x to the fourth plus 12x squared? So again, I want to pull something out of all of these and put it in front of my parentheses. So I look at the numbers first. 9, 15, 12. Well, I can pull out a 3. And x to the sixth, x to the fourth, x squared. X squared is my smallest x. So that's all I'm going to be able to pull out. So I can pull 3x squared out of each of these terms and move it back in front of the parentheses. So 9 divided by 3, that's 3. X to the sixth divided by x squared, that leaves me with x to the fourth. So I'm basically taking 9x to the sixth and then I'm dividing 3x squared. So that becomes 3, and 6x to the sixth over x squared becomes x to the fourth. We did this in homework number 2. Now 15x to the fourth divided by 3x squared. 15 divided by 3 is a 5. X to the 4th divided by x squared is x squared. So I just took 15x to the 4th and I divided 3x squared. So the 15 divided by 3 was 5, and x to the 4th over x2 is x squared. Now 12 divided by 3 is 4. X squared divided by x squared cancels out. There's no x's left. So that would be my final answer. So my answer would be 3x squared multiplied by 3x to the 4th plus 5x squared plus 4. And if you're not sure if you did it right or not, you can always distribute and see if you end up back where we started to see if you factored it correctly. All right. So what I would like you to do, these last two examples, we're going to actually do these we'll do these in class. We're not going to do them here on the video. I think you've seen enough examples that you can solve most of the problems. So what I would like you to do is homework 3C. You should be able to do all those problems on your own. And then next class period, so next class, we're going to answer questions from homework 3C. And we're going to do a couple more examples. We're going to do these 4 examples. So we'll do our examples. And we're going to kind of expand on this just a little bit so that we can do homework 3A, B. So get homework 3C done. I feel comfortable. I feel confident that you can get those finished. If you have questions, if you get stuck, some of you might just be ready to ask questions when you come to class. We'll see you then.